All right, today we're going to look at perimeter, area, and volume. These are concepts that we've looked at already, so you'll notice today it's going to be not as straightforward as we're used to dealing with, as we're going to look at some more irregular shapes. But just a quick review, let's just remember that when we look at perimeter, we're talking really about a one-dimensional look, which is typically, we're just looking kind of the length and could be the width, but it's really just dealing with just one unit, and we're measuring whether it's the sides of something. So it would, on a square, we want to know if it's 4, 4, and 4, and 4. Hey, that's measuring the outside alone. With area is a two-dimensional, whereas we're taking a look at really, well, what's on the inside of the box. So really the big difference between area and perimeter, talking about with perimeter is measuring just the outside. Again, it's a one-dimensional approach, and we get to area, we're talking about a two-dimensional approach where we're really saying what does it take to fill that that shape on a one-dimensional surface. So we're not really dealing with depth yet, because when we talk about depth, that's where we talk about volume, which is where we start to see the 3D or the three-dimensional look. And in that, we're going to start to talk about shapes that have they've got depth, they've got length, and they've got width. So it's something really that I can physically hold, and in that I'm measuring with volume. What does it take to completely fill that shape? So this is really what we're going to kind of take a look at today. Again, with you guys, I'm taking it a step further and looking at some irregular shapes, but really, to start our conversation off, let's keep it basic and just kind of establish a groundwork of understanding. So with this, I have a rectangle. It's not a square because all sides are not congruent. But what I'm looking at is roughly, and these measurements aren't accurate, and I'm just going to use numbers, and we know that those would be coupled with units, but this is 5 units, and we could call it inches, centimeters, meters, miles, whatever, but it's 5 units is this side, and I know up here is 6 units. Now, things that I want to be mindful of when I'm dealing with right angles, which these are, is that the opposite sides are congruent, meaning that this side over here must also equal 5 when I'm dealing with these right angles as such. And likewise, this side here is congruent. And so we start to see that helps us understand that I don't necessarily have to go 6 plus 5 plus 6 plus 5 as a way to solve perimeter. So if I wanted to do P equals, I could call it side 1 plus side 2 plus side 3, running out of room, plus side 4. I mean, that is definitely one way to look at it, but a more sophisticated way to look at it, when you're dealing with a quadrilateral like such that has 4 right angles, or even just don't have to have 4 right angles, as long as opposite sides are congruent, I could look at perimeter in a way such as P equals S1 times 2 plus, as long as it's not the, so when I say S1, then if I'm labeling them S1, S2, S3, S4, I need to make sure that the next one is S3 times 2. And it's just, again, a way to look at it to where I could say, in this particular one here, using this equation, I could say P perimeter equals 6 times 2, because there are 2 of these sides, and then plus 5 times 2. And then if I simplify that expression, it would be 12 plus 10 P, or the perimeter is 22, which is the case over here. Where I want you to be very careful with is to just don't assume that I think the wrong way to go about this is P equals 4S, meaning P equals 4 times the side lengths, because that that could lead you astray, particularly in this one. If I said, well, that means P equals 4 times 6, therefore P equals 24. Well, not all side lengths were 6. So you definitely want to just make sure that you're dealing with. So there are definitely some shortcuts that can get us, you know, a little simpler than right here. But when it comes down to it, this is really where you want to be in terms of your formula. Perimeter equals in any shape, and we're looking at a quadrilateral, but it's all sides added together. So should this have been a you know, another shape with additional sides, I would just keep adding those sides. So there are definitely shortcuts that you can kind of look at. I would say that, and when I say shortcut, you're not mathematically doing anything wrong, but there are just different ways to look at it. This is definitely one of those ways, but you just want to make sure that in whichever way that you start to simplify expressions within those shapes, that you don't compromise, you know, perimeter equals all sides added together. Now likewise, and let me kind of erase this, and if you need to go back and review, you can. Likewise, let's take a look at a shape and talk about area. So we've got this shape here, and I'm going to label I'm going to use the units to help me here, but this is 4 by 3. Okay. Now, when we talk area, there is a perimeter, and I'm sorry, not a perimeter, a formula. Area is length times width. Okay. This is within this quadrilateral. Anytime I go length times width, I'm finding the area. So first thing is let me define area for you real quick. Area is the number of boxes it would take, meaning a 1 by 1 box. So in this particular shape, this here is a 1 by 1 shape, and what it's asking when you talk about area is how many of these will it take to fit here, to cover them up. That's the ultimate question. When you're talking about area, you're saying, if I have this right here, what's it going to take if I were to lay one and to completely cover this shape up? Now the formula is simply area equals length times width. So area equals, I know, 3 times 4. Area for this shape here would be 12. We haven't assigned it, so we would say units square, because it's two-dimensional, length width. But let me show you how that works out. Why is it 12? And I'll use my measurement here, is that if I were to take, now let's zoom in here. Let's take a real good look here. So I've got my shape here. Now watch this. I'm going to take it and I'm going to cut it into rows and columns. Now in doing so, I want you to notice that each of those, it's equivalent to this guy right here. Okay? Now count them with me. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is here. And that's what we're talking about there when we talk about area. Area is you're calculating what would it take to take whatever the unit is. If I wanted to say that was inches, it's 4 inches wide, 3 inches long, and if I were to say, hey, what's the area of it? Well, if I took 1 inch by 1 inch squares and laid them on that rectangle, how many would it take? And it would take 12 of those. And so that's what you're looking at with area. But again, these are things that you have been dealing with for several years, and you're kind of like, got it. But what I want to do is I want to take a look at what happens when we see irregular shapes. So let's take a look at this shape right here. Now in this, and here's where I want to pull in a little bit of last week, we've got some unknowns. So the first thing I want to do is let's talk about the perimeter of this shape. And in the perimeter, what I'm looking for is what is the what are all sides added together? Well, if you'll look, there are, I've got this side, check. I've got this side, check. This side's check. This side is for here, check. I don't know this little side here, and I don't know this side here. So I have some unknowns here. Now, a couple of different ways to look at it. The first way is that, and let me take a more straightforward approach, and let's just kind of total up side plus side plus side plus side, is I can calculate. What I'm going to look at is I'm going to look at the left and right sides first, and then I'll look at the top and bottom sides, okay? So the first thing I know is that I can set it up. I know that this side over here is 9, okay? Now what I know is this side length on, these are right angles here, okay? All of these are right angles. I know this has to be equal to these two sides added together. Okay? These two sides added together have to be the same. So, I could set an equation up. 5 plus some side I don't know has to equal 9. Do you see that? Watch it for me. 5 plus I don't know this number has to equal this over here, 9. Now, kind of go back to where we were last week. I solve for x. I want to isolate. Subtract 5. Subtract 5. This goes away. X equals what? 4. So I now know that this is 4. So I've used a one-step equation in geometry to help find a side length. I could do the same thing with the top and bottom. Okay? The longest side I know is 10, right? 10 equals 6 plus some number. Now again, mentally you're doing this. Mentally, I get it. You're taking and you're looking and you're quickly saying, well, x equals 4. But what great opportunities to practice and to see it in a more real-world scenario. 4 equals x. So I now know that this guy here is 4. So now I could take from a perimeter standpoint and go, add them all up. I know that these side, the bottom and top are 10 and 10, so I could go 10 times 2 to get my top and bottom, plus 9 times 2. And so my perimeter would be 20 plus 18 and 38 would be my perimeter. 38 units. Okay? So that's the way I can look at solving for these missing information to find perimeter. Now once I've done that, now I can kind of work at it and say, well, let's take a look and say, well, what would the area be? Now we filled in some information already. One of the things here is you need to learn to look at these shapes and kind of deconstruct them in a way that you see multiple shapes. Sometimes 2, and it'll get you where you want to go, and sometimes it takes maybe 2 or 3 or maybe even 4. So on this one, for example, I can see 2 quadrilaterals put together. You see what I've done here? This could be shape 1. This could be shape 2. And so if I were going to calculate the area for shape 1, which on shape 1, its area equals 4 times 4. Area of shape 1 is 16 units square. Area 2 is 6 times 9. Area 2 equals 54 units square. And then I want to add those two together to get 70 units square. So when I need to make sure that I take these two and add them together, because up here they are together. Okay, so it's 70 units square. And so I definitely want to just make sure that I'm putting those back together. But all I did is I take a look at it and then kind of deconstruct it. So we'll take a look at let's take a look at another one like that. Here's one that and we'll just talk area on this one because I don't want to run too long on time. I'm already at 15 minutes, so sorry about that. You guys know how I am with that. But in doing the area, we'll work through some of the missing sides, so we'll see that to help find the perimeter. First step you have to do when you see a shape like this, say, well, how do you want to deconstruct it? Multiple options. There's no one right way. You could do it a couple different ways. You could take this way, 1, 2, 3, 4. You see them? So you've got kind of the 1, 2, and then the 3. Or the other way is you could do it this way and then cut it long ways. So both are going to give you the right answer. I mean, I could even, if I wanted to, cut it, down there, but I'll go across. So on this one, I'm going to go, here's box 1, box 2, and box 3. I would always sketch this out on a sheet of paper and just kind of show your work so that you kind of visually don't sit there and try to stare at it. But when I look at the area of box 1, I'm seeing a 7 times 3. Area of box 1 is 21 unit square. When I look at box 2 now, we've got missing information because this 3 here is talking about that side. I don't know this. So I can come over here and say, well, this, and this have to equal 10. So 3 plus 3 plus x equals 10. This would be 6 plus x equals 10. Subtract 6, that goes away. X equals 4. So I know this is 4. You with me? So that becomes 4, and I'll get rid of this. But again, using those equations, combining like terms. So now I know that's 4, but I'm still not where I need to be because I don't know. I've got one side. I don't have the other. I have to go right back to the drawing board. There is I know 7 is up here, right? I know that. I know 3 is right here. So some number plus 3 has to equal 7. Do you see how I did that? Because I need to know this guy right here. And so this plus this have to equal 7. So x plus 3 equals 7. Subtract 3. 4 equals x because that crosses out. So then this becomes a 4 here. So then area 2 is 4 times 4. Area 2 equals 16 units squared. And I'm not done. I keep on going. Now what I do know here, this is the easier one, is if you look at box 3, if the top is 7, then the bottom has to be 7, as long as, again, keep in mind those right angles. So then area 3 is 3 times 7. Area 3 equals 21 units square. And at the end, take them, add them all up. 21 and 21 is 42. So and let me just show my work here so that I definitely want to model what my expectations are for you. 21, 21, and 16. 58 units squared would be the area of this whole shape. So again, different ways to look at them. Okay. Now let's chat volume real quick. With volume, you know that it is volume equals length times width, and then we're bringing in height. So the volume takes a three-dimensional look into it. With this one, I'll just say it's 4, 4, and 4. And we look at that, that's simply and volume of this would be, and we're not specifying the unit, it can be inches, meters, miles, centimeters, whatever you want it to be, but 4 times 4 is 16 times 4 is 64 units, and this one will be cubed because we're using length, width, height. That's where we get that cube from. Okay. Now what does that mean? what this means, and I want to kind of visually draw this out for you, is, and I hope I can represent this well. Okay. This is as close as I can get to a little cube. Alright, so I have my cube here, okay? Not bad. What we're asking is, if we were to fill this box up, okay? If we were to fill this box up, oh, sorry guys, I got this little function turned on now. If we were to fill this up, the question is, how many would it take to fill this up? That's what volume asks. Is if you've got this box that is we'll call it 4 feet wide by 4 feet long by 4 feet tall, and if I had 1 foot by 1 foot by 1 foot, which was what this is. This guy down here is a 1 by 1 by 1. How much would it take to fill that up? That's the question of volume when you're looking at volume. So therefore, that's why volume is cubed. It's because it takes a length, width, and height. So let's take a quick look at one, and then I'll cut you off, because I definitely, again, my focus is irregular shapes with these. So we've got this shape here. We'll take a closer look, and we'll notice that we've got some basic information, but we don't have all the information we need. Again, my expectation here is that you need to learn to see these in a way that you can kind of tear the shapes into multiple shapes that you can work length, width, and height. Clearly, if I were to take length, width, and height here, it would be 7 times, and I'm trying to think the easiest math for me, and I could do it. I could say 7 times 6 is 42, right? I go 6 and 7 times 5. And so I go 42 times 5, and that's going to get me 210, is that right? I think it is. And so it would be 210 units cubed. The problem is this shape isn't consistently 6 by 7 by 5, because it has some indentions that take those dimensions away. So that's why that's not correct. So what we need to do is we need to think about how can we take this and turn it into 2 different shapes. So I'm going to take and I'm going to cut this little piece off right there. And all of a sudden, do you see how I take this off? And I'm going to focus on, I'm going to use my highlighter here. I'm going to focus on this part as the first shape. And then I'm going to focus on this other part is going to be the second shape. Now be mindful, this piece here, this green, it goes in there behind it. So we still have to use the whole 7. But in doing so, it changes it up a little bit. So now I'll focus on yellow. So we'll just call this yellow 1. Yellow 1 to be length times width times height. I know the height of the whole thing is 5, so that 5 is going to hold true here. And then look over here, so 7. So this has to be x plus 5, because these are both lengths, has to equal 7. So then I know that this is 2, right? You see how I did that? Some number plus 5 equals 7, because I'm comparing those lengths on each side, trusting on my 90-degree angles, making sure that opposite sides are congruent. So now I do have something to where I can go, the yellow is going to be 2 times 2 times 5. So Y1 would be 20 units cubed. Now I go to my green. I've got this side over here I don't know. But same thing, I look at, again, I'm only focusing on those same sides. So I know the total is 6, which is up here. This total is 6. It runs from side to side. I've got a 2 plus some number equals 6. Well, that's 4. So when I look at my green one, I could say 4 times, that's right, here's my 4. Let me change that so that that's clear. Okay, this is now 4. So that's my width here. My length is still 7. Didn't change on that one. Length is 7. And my height is still 5. Okay? So then now I can come at and say, well, 7 times 5 is 35 times 4 would be 140. So 140 units cubed. And again, same story. I got to add the two together. And so 140 and 20 is going to give me 160 units cubed. And so I was able to deconstruct those, and that's kind of what we're looking at. So this week we're going to be looking at odd shapes like that, and my biggest challenge for you is to don't fall into the trap of just assuming it's a length times width, or it's just add all sides together. Is you really need to think through the missing information, think about congruent sides, think about how you can apply last week. I mean, this is real life stuff where we're solving for X. There is something missing. You have an opportunity. Set the equations up. Don't just stare at it and try to figure it out. Get it on paper. That's where you'll be most successful, okay? Good luck. If you need me, shoot me an email. I'll be here to help you. Thanks, guys.